This is the On Humans podcast, a show which makes new research about humanity more accessible to everyone and more meaningful to the big questions about our self-understanding. I'm your host, Ilari Mäkelä, and today we continue on this autumn's journey to understand the mysterious organ inside our skulls, the human brain. In the past episode, we explored the brain's architecture and music, the areas and the connections, as well as the rhythms and the waves. But today it's time to look at brain spice, the molecules, the chemistry that set the flavor for our experience. Dopamine, serotonin, endorphins, we've all heard these names, but what do they really do? And what can drugs, from alcohol and cannabis to cocaine, psychedelics, and antidepressants, teach us about them? My guest is Judy Grisel, a neuroscientist who in her youth was a heavy user and drug addict, but who was able to get out of her addiction and become a world-leading scientist of addiction. Her book, Never Enough, is one of the best non-fiction books that I've read during the past year. She writes remarkably beautifully and she writes very clearly. I highly recommend that to anyone who's interested in addiction in particular. And indeed, today we do talk about addiction itself, especially towards the end, where we also discuss ways to help people who are struggling with it. But first and foremost, this is not an episode about addiction as much as an episode to understand something that's happening inside each and every one of us every single moment of our lives. So we are going to take a tour of the brain's mythic molecules and ask what everyday life and what different drugs can teach us about wanting, about liking, about pleasure, about pain, and of course, addiction. I hope that you enjoy this. If you do, as always, you can take a moment to support the show. And if that motivates you more, then I'm glad to say that today is the 3-year anniversary of On Humans. So all the more reason to spread the joy if you think that there is joy in this show. You can just hit the subscribe button if you haven't done so yet, and you will thereby also stay tuned to more On Humans episodes. You can also find a way in your podcast app to give me a 5-star review if you think that I deserve it. And of course, if you have someone in your life who you think would enjoy this episode, do share it with them. Now, before we get started, just one final thing, which is that I want to send a warm thank you, as always, to all the wonderful people who support me at patreon.com/onhumans. Your support really matters. Thank you so much. And as always, this episode is for you. Now let's go. Professor Judy Grisel, welcome to On Humans.
Thank you, Larry. I'm happy to be here.
I don't think anyone listening to this will have lived their life without sometimes hearing about brain chemicals, serotonin, dopamine, endorphins. You are someone who actually studies them. Having been an addict and then becoming a neuroscientist of addiction, what would have been your strongest moment when you saw something in the science that really spoke to you from experience?
Wow. There are so many of those. So my aha moments have kind of come along with discoveries. Lately, I'm very intrigued by our expanding understanding of dopamine, not as a pleasure chemical, but more as a meaning signifier. And that really resonates deeply with me. I also remember a time early on when I was just in grad school learning about endorphins and their sensitivity to alcohol. So, alcohol releases endorphins in some people more than others. And those that have the particularly sensitive system are also prone to alcoholism or alcohol use disorder, as I am and was. So I really connected with that, the feeling of things being wonderfully okay just by drinking. But I think the whole, there's so much left to discover with neurochemistry that, I almost can't wait for tomorrow to see what's new.
Let's start with the point about endorphins. I mean, I first heard endorphins when reading or, something about runner's high. It was like, oh, so this is a feel-good chemical that the brain produces.
Mhm.
Do I remember right that there is even a study suggesting that people who naturally have, was it low levels or low sensitivity or some kind of a natural shortage in some sense of endorphins are more prone to alcoholism, perhaps because there is a kind of inner gap to fill, and that feels like it feels it.
Yeah, this opioid deficiency hypothesis is that either there's less of the endorphins to begin with, or, and sometimes that some people are especially set up to have a big surge in endorphin with alcohol. So if we give alcohol to people with or without a family history of alcoholism, but who maybe haven't had anything to drink themselves, this is studies from the 80s and about 13 and 14-year-olds, some of them, those who have no alcoholics in their family have higher endorphin levels to begin with, but they're not particularly responsive to alcohol. So you could imagine that, it's a kind of ho hum experience relative to someone who has low levels that are totally remediated by a good drink and then some. So I think that for those people, and I think this was the case for me. I remember my first drink really well, and it was truly a almost transcendent feeling of wellness that is very much what people experience with, especially people who aren't regular users of morphine, let's say, or heroin. So just a feeling that things were good and perfect as they were, and that was like a sudden surprise to a 13-year-old who, was full of insecurity and doubt and angst. So, yeah, I think it's one of many factors, chemical factors, but alcohol is a sedative, but it's also a kind of euphoriant.
I think alcohol is an interesting place to start because it's probably the one that most people listening will have some experience. And definitely, if not personal experience, then they have witnessed its effects. So you mentioned also the fact that alcohol is a sedative. And I was chuckling quite a lot at a line in your book. I can't remember it from the top of my head, but it was something like you're curious about the fact that our cultures around the world tend to celebrate big moments and victories with a sedative. A sedative meaning something that it reduces energy levels. At the end of the day, sedates you enough to literally pass out. How much do you think that the real paradox of alcohol is exactly the point that it is a sedative, meaning it relaxes muscles, it reduces brain activity, quite literally,
Right.
which is not necessarily what people always want. But at the same time, it does have this endorphin boosting quality. So is that kind of why, sometimes the drunk is a great one, you get a lot of endorphins, sometimes it's a rubbish one, you just feel crap because you got the more sedative part? Or is there is it a more complicated picture?
Yeah, good question. I think any drug is used either to kind of get the party on and feel great, which would be, in this case, maybe endorphin mediated, and also, or instead, to remove negative states like anxiety or loneliness or, the edges of a rough day. And that way, and that's so we're talking about positive reinforcement and negative reinforcement. Positive reinforcement in classical psychology is giving something good, and negative reinforcement is taking away something aversive or not good. And alcohol is kind of a master at both. But for some people, maybe more one than the other. And if you have a lot of sedation and you're anxious, for instance, to begin with, you have anxiety in your family or in your history, then alcohol is going to be particularly uh, appealing because of its negative reinforcing effects. There's some evidence to suggest that females in general are more inclined toward the negative reinforcement because they tend to be more stress prone, and males, especially young males, the beginning of their drinking careers, like more of the positive reinforcement. The sedative effects, by the way, are due to enhancing GABA, the neurotransmitter
So GABA, is that right?
GABA. It's a neurotransmitter that is responsible for most of the inhibition in the brain. So most of the shutting things down and slowing things down. So alcohol stimulates activity at GABA synapses, the connections between brain cells or neurons. And it also inhibits another transmitter, glutamate. So, glutamate and GABA are kind of in a dance, a yin yang kind of a thing. GABA is slowing things down, and glutamate is speeding things up. So, what alcohol does, it enhances GABA, the slow down neurotransmitter, and it slows down glutamate, the speed up transmitter. And in both those ways, it's reducing brain activity to make you think slower, walk slower, speak more slowly, and maybe slow your words, maybe, as you said, pass out.
But also slow down the inhibitions, cognitive control, the anxiety.
Yeah, well, the reason that happens is interesting because um, our limbic system is subcortical, so it's below the surface of the brain. The things that you just mentioned, the inhibitions and the reasoning and you know concerns, those tend to be more on the surface, so more on the conscious part of the brain, and alcohol affects that cortex more quickly. And as it shuts down our ability to kind of regulate our emotions, then the limbic system gets kind of unencumbered. And the way that comes out is, so it's really due to sedation that hasn't quite gone to the core of the brain, the limbic system. So you're sedating reason and impulse control. And now your impulses are free to express themselves. If you keep drinking, those also get shut down too. And then people are passed out. So it kind of goes from the top down to the brainstem. Yeah.
So kind of a brain chemistry triangle of the effects of alcohol is that on the one hand there's the endorphins, that's just the classic kind of feel good part of it. Then that's the positive reinforcement. Then there is the shutting down, the thinking, the anxiety, that is the kind of cortex surface of the brain. That's the negative reinforcement that might feel positive. But then there is at the end of the day, it is a sedative. Everything is going to be a bit slowed down in the long run. So you're going to become worse at driving a car. You're going to be, at the end of the day, worse at
No.
doing anything.
And with number one, it's endorphin and dopamine, which I know we're going to come back to, but I don't want to say it's entirely endorphin.
Okay, well, let's talk about dopamine. And this is something that fascinated me when I was an undergrad and I was reading brain science and in my psychology courses. And I remember a lot of it is very technical, especially when it comes to the brain stuff. A lot of complex words, a lot of acronyms. And then the one time that really just was not the case, we were talking about hardcore neuroscience, but that just wasn't the case, was when I remember reading a paper about the difference between wanting and liking. And here was something that was said in plain English. There's a difference in the brain between wanting and liking. And dopamine played a key role in what I remember. Correct me if I'm wrong, I think the original study was an animal study with rats, and there was it so that they basically blocked the dopamine pathways of a rat, and it wasn't really that the rat couldn't experience pleasure. It would still, like, if you give it sweet things, it would be licking the sweet thing, and it looked like kind of like it was enjoying it, but it just didn't have any motivation to really work for anything. So that there was the idea that, okay, the rat is still liking these things, but it's not wanting. It doesn't have the motivational oomph to go get it. And that seemed to tilt the understanding of dopamine away from it being just a dopamine equals a nice feeling to dopamine equals wanting something. And you can, in some cases, dissociate those so that you keep wanting things even if you don't really enjoy them. Is that original finding still, do you think it's still kind of a good way to understand dopamine, that it is much more a wanting than a liking thing, much more a go rather than a this was good thing?
Yes, it's definitely not this was good. It's that this might be good. It's the anticipation, it's curiosity, it's hope, it's expectation, it's promise,
Hmm.
and that is really what drugs convey. Addictive drugs, they're not so much pleasurable, but they have they sort of are a signpost for something really valuable. One of the studies I love, this is kind of so interesting to me, but it was in humans, and they came, I think, 2 weeks in a row to hear about possible travel packages. So it was purported to be a some kind of an travel agency trying to figure out which place was more appealing, and they agreed to take a, a pill each visit. I think they were a week apart. On one visit, they took a drug that stimulated dopamine, and on another visit, they took a placebo. And then they heard about, I can't remember where it was, maybe, Tahiti and Bora Bora or something. And half of them got Bora Bora with the dopamine stimulator, and half of them got it with the placebo. And then they switched the other week. And it didn't matter which place it was. Um, they universally preferred to think about going to the location where they had been under the influence of the dopamine agonist.
Agonist being a booster.
Yeah, the booster, thank you. It just looks really good there. I think I would like that place very much. So it's this, the feeling you have with a present sitting wrapped on the table is dopamine, and dopamine really helps orient us to um, potential good things, to potential meaning.
And would it be right to then, if we take this wanting versus liking, where dopamine is more this wanting, this, which might be the pleasant moment, like you said, you're
Mhm.
looking at the present, that it is actually often the anticipation that is most exciting about it. But it can also be anxious. Anyway, so there's this whole wanting part. But then looking at the liking part, am I right that that's there? Endorphins would be one example, but they're the chemical profile of what does it look like for the brain to, or what's the chemical alphabet of actually liking, of opening up the present. And sometimes it is a wonderful present and you get a sense of wow or a sense of peace or whatever.
Mhm.
My impression is that we don't really have, in the same way, like one thing to tag on to the liking part of the brain as a chemical. That, yeah, endorphins are part of it. Endocannabinoids are maybe part of it. Maybe serotonin is part of it. Like
Yes.
I keep hearing all sorts of things that are maybe part of some kind of liking, but it gets much messier there. Is it just that I've been misreading the literature, or do you think that there's a genuine way that's it's a messier bit of the brain?
I think it is messier, and it's a much more, real estate in the brain too. So,
Okay.
the one thing about the dopamine pathway is it's very small relative to all the other systems you just talked about, serotonin, the endocannabinoids, the endorphins. All of those are kind of all throughout the brain. But dopamine is relatively sparse. There's not very many neurons, and they seem just to, um, play a role in a few things, including, um, yes, including the wanting and including the curiosity and the promise, and also conveniently in movement, voluntary movement. So it's interesting that once you get that signal that this is something that you want, um, then what do you do? And as you said, one of the curious things about the or you alluded to this, I think, pretty in a way. It doesn't have to be pleasurable. So dopamine goes wild when we deprive somebody of oxygen.
Okay.
And that's really no fun. So if you've gotten your PADI license or something, you might know, but it's a bad feeling. But it's because that is very potent. That is very meaningful. And then, of course, the what you do with that meaning is move either toward or away from something. But I think this is a system that plays a critical role in our our seeking to change things. And first, it signals us when something is important, and then it kind of helps enable us to turn that value into an action. So, all addictive drugs and all addictive processes are addictive because of their capacity to leverage this dopamine system. So, because they kind of masquerade as something meaningful, something that is what you like, you know? So we don't naturally like white powders, but it feels like we do, when we use certain ones of them. So, for instance, cocaine is a very potent way to enhance dopamine levels. And of course, what's characteristic of regular or even irregular cocaine users is that they always want more, right? Wanting, wanting, wanting. The psychedelics don't seem to release dopamine. They're really not addictive in the classic sense because we don't see any of this wanting kind of thing. But the and animals other than humans won't generally self-administer them, and they will self-administer every other thing that we think of as an addictive drug.
Oh, really?
Yeah,
Interesting.
yeah, including crazy things like hot sauce. And they'll, self-administer risk, so, like, the, sort of precursor to gambling or certainly access to sex or, you know, stimuli associated with opportunities for sex. So all of those things are addictive because of the dopamine system, because this drives this kind of I want it, I need more and more and more. And psychedelics, I was just talking to someone this week who used them in therapy, and he's a therapist, and he was given psychedelics one time by another therapist to try to work through something, and he said, "I did not like it at all, but it was very helpful, and I appreciated it," So that would be more. Yeah, those are a different animal entirely, I would think.
And the main molecule there is serotonin, right?
Serotonin, yes.
Which would, of course, be very familiar to most people from depression. So serotonin is the typical target of antidepressants.
Yeah, not particularly effective to target those, though, we know now. So, the antidepressant drugs are very widely used, but depression is through the roof. So, just on the face of it, we can't have found a panacea for depression. And in fact, the neuroscience community is kind of turning away from serotonin, and I think people associate serotonin with mood, and it certainly is involved in mood, as are glutamate and GABA and, all kinds of things, dopamine. But I think that, serotonin, unlike dopamine, is all over the brain. It's involved in arousal, it's involved in sleep, it's involved in, cognitive processing, it's involved in anxiety, it's involved in sex drive, it's, body temperature, feeding, all kinds of things. So I think that the psychedelics, they seem to increase neuroplasticity, which is the ability of the neurons to change the way they talk to each other. And so they kind of put us in almost a developmental, like a child state where things are kind of fresh and differently perceived, and we get in neural ruts, we carve out these pathways that are used over and over again, and in a way, sometimes, it looks like depression is a lack of imagination due to excessive, rutting, I guess, of our ways of thinking.
Yes, rumination, thinking about the same things all over again. Yes.
Yeah. I think one thing though, Hillary, is that if you take an SSRI, within about 25 minutes, you've blocked the reuptake of serotonin, but you really don't feel better. If you're going to the doctor for the first time, they'll say, 2 or 3 weeks, give it 2 or 3 weeks. That does not reflect the acute or the immediate action of the drug in the synapse. So it's really, it requires this long kind of therapeutic lag. And that is attributed to the fact that the SSRIs induce your brain to change its wiring a little bit. And that takes time. Now, MDMA is interesting because that also blocks reuptake of serotonin. and yet it produces immediate and profound antidepressant effects.
And I would guess that in popular culture, one of the reasons why this kind of serotonin is happiness molecule or depression is just the lack of serotonin. My bet is that one of the reasons it has become so popular is that it is so well supported by the idea that, look, take an MDMA pill and you immediately feel the opposite of depression. You feel great. So I'm very curious to think, what is the difference? What do we understand? Why does MDMA do it immediately and SSRIs don't?
I think it's much more potent at not only blocking reuptake, but at flooding the synapse with serotonin. So, unlike the SSRIs, MDMA gets transported into the cells, into the neurons. And in doing that, it causes a massive release of serotonin. So, well beyond the acute effects are well beyond what you would see with an SSRI, which is not really increasing release, it's just slowing down the recycling. So, I think that is the big difference.
But it does then suggest that, okay, although this is a very difficult, the opposite of dopamine in a way, that dopamine is a very localized, quite easy to, and we have very good models of how it works. It comes from here, it does this thing. With serotonin, it seems to be quite the opposite. It goes a bit everywhere. And the serotonin, that's the chemical, but then you need the receptor, a bit like you need a key doesn't help if you don't have a door to open it. And there's so many doors you can open with serotonin, like, and you get all these, like, serotonin receptor 1A does this and 1B does that and 2A does this, and my head hurts. However, the MDMA example, it does seem to suggest that that there is some kind of very strong link between serotonin and mood, because this immediate flooding of serotonin with MDMA, for example, does produce such robust, elevated mood. What do you think about that?
Yeah, it could be. It could be that we're making a mistake, though, because every neuron is connected to every other neuron. And if you have this sort of super physiological levels of serotonin in synapses, those synapses are going to connect with other transmitters. So it could be the consequences of this huge surge, like this flood in serotonin that leads to floods or dearths, in other spots.
Okay, so there has so many downstream effects that we don't really know what makes the mood.
Yeah, I think that's a little bit of a guess. And, dopamine has 5 doors, it has 5 receptors. Serotonin probably has 17, and they're much more diverse. The dopamine system has like 2 general types, and serotonin has multiple types that we're still trying to understand. So it may be that in particular synapses, 1 or 2 or 3 of those types, who knows where they are and which types they are then causing consequences for maybe some of the endorphins. Endorphins also are all over the brain doing many, many things. So there is really no island in the brain. There's no mood place. It's kind of a whole brain.
But what we do know, am I right, that there is one serotonin receptors, one of those doors, was it 2A receptor, that psychedelics particularly work via?
Yeah, it seems to be responsible for opening those 2A receptors, but we don't fully understand what that does because those are all over the brain. They're in different spots on different neurons, and they may. One study I remember very old is that um, when the psychedelic, I think it was LSD in this case, went on the cells got really, really quiet, like they just stopped their activity. And that was due in this study to activating the 2A receptors, which were kind of talking to the same cell they were that was releasing serotonin. So serotonin would be released from a cell and then it would stimulate itself, the same cell that released it. And that stimulation at 2A receptors would get the cell very quiet. So it would sort of shut off the cell like a negative feedback system. And when it shut it off, then there was no more serotonin release. And that serotonin release, and so all of a sudden the serotonin goes from kind of chattering away to virtually silent. And in that space where the cells are no longer being kind of filtered by serotonin, then they're kind of unencumbered to go ahead and maybe open up this plasticity. So it's very interesting.
Okay, so basically serotonin, super complicated. Anyone who tells you that serotonin equals this or equals that, probably run away. Don't trust what they say.
We're always wrong, you know, and
Hmm.
this is sort of the delightful thing about science. If you
Hmm.
can appreciate the ever increasing, kind of our questions get better and better, and we rule out things. When one thing we've ruled out is that dopamine is just responsible for pleasure and serotonin is just responsible for mood. So I think it is complicated, like the, universe is complicated, that we don't understand so much about the brain, and we haven't even discovered, I've heard, most of the neurotransmitters. So we're still, kind of trying to understand what are the chemical signaling. We have a few ideas, but we should be really mindful about trying to attribute everything in our experience to those relatively few ideas. But I did want to come back to this. I know of a cool study by, I think it's Barbara Sahikian in England, where she gave antidepressants, SSRIs, to people who were not depressed. And they reported kind of less sensitivity to everything. And so this is a way maybe to treat depression because you feel vulnerable and, um, you know, fragile. So if you can just sort of buffer experience, great. But of course, if we buffer psychic pain, we also might buffer sexual arousal and intrigue and interest in other things. So the brain is, as a whole, involved in all kinds of things. So we don't really have particular chemicals or particular pathways for specific things uh, that are isolated, I guess.
The question of how we understand and how we treat depression, of course, relates to how we understand and treat addiction. That would be a topic I'd love to hear your thoughts on. Before we go there, if we think of chemicals, we've covered quite a lot of ground. We talked about dopamine, especially the motivational wanting aspect of it. We've talked about GABA and glutamate, which alcohol influences, which have a dance on like sedating the brain or doing the opposite. We've talked about serotonin just now. And then we also mentioned endorphins many times, endorphins, which are the body's own kind of opioids. But it's not only the body's own opioids that we also have endocannabinoids, so the kind of brain's own form of cannabis in a sense. So that to me is a bit more in the serotonin ballpark of, well, this looks very complicated and I don't think I've been able to really get what are these doing.
Yeah, Hillary, you're very humble. And I just want to say that you're in good company. So neuroscientists are not very clear either. And none of us really understand, as we're saying, any of these systems thoroughly. And endocannabinoid system is maybe the most exciting and the most mysterious at the moment. It's the most recently discovered. It was only in the 1980s that we really began to, we found the receptors and then eventually found the endocannabinoid molecules, which are 2-arachidonylglycerol and anandamide. And those are chemicals that interact with the cannabinoid receptor, just like THC does. So THC is in a way mimicking, it works because it mimics anandamide and 2-AG or 2-arachidonylglycerol, just like morphine works by mimicking endorphins.
Yeah, so smoking marijuana, THC being the active component there, mimics this thing that we naturally produce. And anandamide is, that comes from, I learned from your book that comes from Sanskrit word for bliss.
Yes.
So I presume
Yes.
that these endocannabinoids have something to do with the peaceful liking, being satisfied. Is that right?
I would say no.
Okay.
Uh, so THC for some people produces that feeling of contentment. Other people, it produces feelings of paranoia. So it's not a, one size fits all. It's not a cocaine, in terms of specificity at its action. And one of the reasons, that we've already kind of been discussing is that cocaine acts particularly at these dopamine synapses, and there's not very many of them. THC acts at cannabinoid receptors, and there are trillions of them. They're so prevalent. In fact, those cannabinoid receptors are probably in every synapse in the brain, which is not like any other chemical system we know of. But it is really noteworthy that the endocannabinoid system, this natural neurotransmitter system, is especially active at times of high neuroplasticity during prenatal and early postnatal development, and again during the adolescent period. And what people think is that it plays a critical role in sculpting the brain. And those times, prenatal, early postnatal, and adolescence, are the time when the brain is undergoing the most remodeling. So we believe that the endocannabinoids are shaping the plasticity or the changes to neurons and their connections. But there's one study I love. If you take a cortical cell in a dish, I think it was a rat in this case, and if you give it THC, it blows up really early. So it looks great because it looks like it boosts the neuroplasticity in this cortical cell. So, it was going to be sort of puttering along, slowly growing its connections, and all of a sudden it's kind of fat.
Oh, so it would be like weed is like a fertilizer for the brain.
It is like a fertilizer. However, 2 weeks later, that same set of cells, that got them earlier are now shrunken.
Okay.
So it sort of disrupts or, you would assume that naturally these levels that are going waxing and waning, especially waxing during these times, are boosting or fertilizing the brain to make new connections. And that by taking THC, just like putting too much fertilizer on at the wrong time, makes the grass really green at first and then it kind of burns out. It looks like it's the same sort of thing. So I think that these chemicals are going from the receiving cell back to the sending cell in order to modify that synapse for future use.
I don't think we could do justice to the addictive profile and the health risks of each of the substance that we've discussed. But you have, I think, a very telling line in your book about the way that excessive use of marijuana, of cannabis, can backfire. And I think that without focusing too much on specifically weed, I thought I would read this and ask you to discuss what the general lesson here is. So you're writing about a friend of yours who has been a heavy user of alcohol and decided to change from alcohol to cannabis and found that it helped him feel like he's a better dad when he smoked a joint. And the line from your book goes as follows, quote, "With just a couple of hits, he was able to play more with his children and didn't find the carpool, meal preparation, or team coaching quite so irritating and tedious." "Great," I said. "How is it with your kids when you're not high?" And the response was, "Increasingly irritating and tedious." Why?
Regular use of any addictive drug or process, like pornography or food addiction, creates the very states you're trying to avoid by using the drug. And this is a long story, but essentially, the brain counteracts external means of changing its activity. So, by making things like the carpool line really rich and interesting, we end up making daily life less so. And it's the case with every drug. If you take a drug to reduce suffering, like an opiate, you cause pain. If you take a drug like MDMA to feel connected and whole and loving, you end up feeling alienated and depressed. It's really the consequence of chronic MDMA use. If you take a drug like alcohol to relax and cope with stress, you become more anxious and more easily stressed and don't sleep as well. So sedatives produce anxiety, euphoriants produce sadness and despair, stimulants produce lethargy and, a lack of ability to focus. It's just what happens with chronic use of any of these.
There's something that makes a lot of sense about that. The idea that you're kind of the brain creates a new, just with caffeine, you could imagine experiencing the thing that you start getting more and more tired without coffee in the morning if you keep drinking a lot of coffee in the morning, and something similar happens with all of these drugs. However, there are genuine changes to the positive. You know, using addictive drugs don't normally raise the kind of set point that the brain organizes itself around. But there are times when we can shift brain to be, I don't know, happier, more energetic on a long-term basis. So if I start exercising every morning, it's not going to be that my brain counteracts that in some kind of negative way, that I don't get the runner's high anymore. Why is moderate use of coffee, in my experience, sustainable? I don't feel like I'm particularly tired in the morning, and I drink 1 cup most mornings, and I feel great after it still, after many years of doing that. So why is the runner's high sustainable? Why opioids keep creating pain, and why there are cases like coffee where it kind of, you might be able to manage it so that it like still gives you the boost in the long term. But do we understand those differences? Because that seems to me to be the all important question.
Yes, I think we do. The nutshell answer is that the things that you describe, like running or all the things that make us feel better, maybe scientific discovery or listening to music or building, something, those things are physiological levels of the neurotransmitters we've been talking about. So these are levels that the brain releases naturally in response to doing those things. And these are many of the reasons we do these things, and that's terrific. So we can change the way we feel, and we do it in ways that enhance our well-being and enhance the world, really. But drugs are so potent, especially now, that you're getting much higher levels of these neurotransmitter changes that we've been talking about. And that is not physiological levels, they're supernatural. And so they do induce a kind of lack of sensitivity and counteracting that response. And I think you could say, you don't get deaf by listening to people talk in regular voices. But let's say I really love a certain kind of music, so I turn it up louder, and I love it so much I wanna turn it up louder and louder. Well, I get insensitive. My ear is gonna be damaged to that level. And so then what do? I have to turn it up louder, and now I can kinda hear it, but it's muffled. The message is not coming through in the same way because the cells themselves just cannot respond. And I think that's really what we're talking about. Your coffee situation is interesting though, because you said, I don't drink it every day. I drink it almost every day. That's probably also key. So,
Okay.
because now you're not, flooding your synapse every morning. I have 2 cups now only in the morning, and I can't really put a sentence together without that, so
Yeah, I mean, I do. I'm completely open to the possibility that I have readjusted my system so that I am more tired without coffee in the morning than I was before I started drinking coffee. However, I do think that with the coffee, I do get that alertness boost years and years later in a way that feels quite nice, that doesn't seem to interfere with many things, and I'm still okay without it. But maybe it's just a less dramatic change of a set point. I don't know. But I guess my coffee use is also not the most interesting thing for listeners. So my next question is, the way that something like cocaine completely floods the dopamine system in a way that our bodies haven't evolved to deal with. And that explains the difference between its unsustainability in the long run and running, for example, being sustainable in the long run. But what about behavioral addictions like porn? Because something like a porn addiction or much more mundane, a smartphone addiction or social media addiction, they're comparing that to something like running. There isn't such an obvious way in which one is just natural and then the other one is a chemical flooding. Is there an explanation for why we get blunt in some sense for these things like gambling, porn, but we don't in the same way for something positive like running?
Yeah, well, let me say there are people who are addicted to running. Their knees have given out. Their their bodies cannot really take it, but they can't stop because the idea of not running is painful.
Fair enough.
But that's relatively rare. I think that it has to do with potency. Again, though, pornography, we could get addicted to sex, and some people, what I mean by that is they might have bad consequences from sexual behavior with other human beings, but they keep going because it just means so much. And like everything we've spoken about, that involves all kinds of factors and all kinds of chemistry, probably early trauma even. But having, say, Pornhub in your pocket is almost like having fentanyl in your pocket for somebody who's prone that way. So now we don't need to go to the trouble of finding another human being and going through the small talk. Instead, we can just, get what we want when we want it. And then shortly after that, we can get a little more of what we wanted. And so it's so accessible and potent, say pornography is, or even the gambling. Now people, start gambling really early and they can do it all the time. Gambling has been an addictive problem since, people could throw stones, I think, but not they didn't have access like they do now. So I think this is part of it. And gambling's a good example because we like risk and risk is a good thing. If we were totally risk averse, we wouldn't have, podcasts and we wouldn't have scientists probably and many other things. But you can dampen sensitivity by just overdoing risk. And I will say that impotence is really high in young men now. And excessive gambling and being delinquent on your debts and everything is going up with the access. So it's really the potency of the drug or the process.
And I guess there's also a way which it can be ramped up easily, like so that you can always get the 10% more of a hit or 10% weirder of a video or 10% bigger of a bet.
Exactly. It's unending.
But I liked also what you just said that no risk, this is a good thing. Wanting risk is a good thing. In the beginning, you also said that dopamine is a meaning marker. How do we use that understanding to help people who struggle because substance or a behavior has hijacked their dopamine system?
I have a story about that I was giving a talk not too long ago, and there was a woman probably in her 40s in the second row or something, and she just started sobbing. And as soon as the talk was over, she came up and she said, I had been drinking wine for 20 years or something, and it really got out of control and it affected my family and it affected my children, and my husband was going to leave me. And anyway, I quit and I was kind of hanging on for a while. And then I started spending all of my free time and money on flying lessons. No kidding. So she was going and she felt really guilty and she was crying because what she heard in a conversation like ours is that this desire to fly was really what she wanted. And she was settling for, crappy wine in cardboard boxes. And that, I think what it means in a way is that we shouldn't tell people don't use drugs. We know that does not work. But we should say, what are the ways that you can create? What do you want? Deeply, what do you want? Do you want to study philosophy? Do you want to fly airplanes? Do you want to climb rocks? Do you want to make art? Do you want to be a scientist? Do you want to share news? I mean, there's and really recognizing that not every we're not alike. What turns me on is not what turns somebody else on, and we should honor the craving. We should honor the wanting, but in a way that doesn't kill us or dampen our sensitivity to our very best guide, which is this dopamine.
That reminds me of something I heard. Another addiction scientist, Mark Lewis, author of Biology of Desire, he has a very similar story to you. I've understood he was also a user and used that experience to become a scientist of the matter. And he also said that when he now meets someone who is a user at the moment and he's an addict at the moment, he never says anything about maybe you should stop, but he asks something about tell me what it means for you, trying to find meaning in it and then use that meaning as an anchor.
Mhm.
There is a difference, though, in your approach. You use the term disease, brain disease, when talking about addiction. And for example, his book, Biology of Desire, the subtitle of it is Why Addiction is Not a Disease. My impression is that you two agree on a lot of the ways in which addiction works, also on many of the ways that we can treat it, and yet there is a disagreement about the terms. Maybe I can make his case briefly here, and then you can respond to it and give your case. I mean, his case is that indeed, to fix addiction, we have to talk about things like meaning, about motivation. We have to help people see that they themselves can take control of their own lives. And the disease model, talking about it as a brain disease, can, yes, decrease stigma. But on the other hand, what it often does to people, he would say, is that it makes them feel less empowered. And this can actually make it more difficult to actually recover from addiction. And it can also make addiction feel like a very scary thing for people around if they think it's just something that only the doctors understand. We cannot understand it. Whereas actually it does have to do with these more, in a sense, humane aspects that are understandable, and therefore we can all help addicts. And therefore he has been arguing quite poignantly that we should not think of addiction as a disease. Why do you think that we should keep the disease model in our way of thinking about addiction?
The main reason is because it's so lethal. So more than 5% of the people that die on the planet today are going to die just from alcohol. 10,000 people every day die from addictive use of mind-altering chemicals. So something's wrong. I guess I I don't get, it doesn't have to be the word disease. I think disease is very squiffy. Behavioral diseases or disorders are notoriously hard to put our fingers on. When is someone obese? When is someone excessively anxious? And when is it kind of good anxiety? These are not easy. But I do think that something's wrong. And I think we do agree. I agree with Mark on the fact that um, we need to be empowered. And I think one reason I was able to recover is because I was able to not find my airplanes, but find uh, my meaning. And I had opportunities to, kind of move on. And I do think I agree with him that we need to focus on ways to help people who are really feeling pretty lost and hopeless to get hope. And it's not maybe only by saying, something's wrong with you. So I get that point. But I think for me, it was really helpful to recognize something was wrong. What I was doing was killing myself. So then it's both. For me, it's recognizing that things are not going well with some individuals and with society as a whole that is full of escapism. I mean, we're trying to escape the situations that we're in, and those situations, if I may say, are just getting worse. So the more we medicate, the more we're insensitive to it, the more we're kind of maybe denying it, the less we're able to respond. But I completely agree with Dr. Lewis that we're not going to get anywhere by shaking our fingers and telling people what not to do. That the war on drugs is an abject failure, and shame does not help. But we do need to go the extra mile then and give people opportunities for remaking their lives that have meaning to them.
Well, I think that's a good place to start coming to a close. Always my final question is, how has all your work shaped your outlook on humanity?
Well, I spend most of my time with undergraduates, and I have the benefit then of eh, close contact with 19 and 20-year-olds from all over. And I am hopeful. They are hopeful. I do believe that we have a goodness at our hearts. We have curiosity, we have empathy, we have plasticity in our brains and in our policies, maybe to adapt and to become better versions of ourselves. So I'm working with those undergraduates right now on an initiative to share scientific evidence about addictive drugs on social media so that young people can get the kind of information that they need. I think young people are the future, and yeah, I'm really grateful to be in a position to see them every day.
Professor Judy Grisel, thank you so much for your work and your time today.
Thank you. It was a pleasure.
Okay, so that was it for today. Thank you for sticking with us until the very end. If you are a careful listener and you listened to the past episode also till the end, you would have noticed that there was a plan to have an episode on the history of neuroscience before this. Now I decided to swap the order, and so the final episode on the brain series will come out in a couple of weeks, and that will be with Professor Matthew Cobb, who will talk about the glories and the worries of neuroscience, asking how close, if close at all, the best brains in the field have come to understanding themselves. Until next time, take care.